Welcome to our tutorial video for DJI Matrice 4 series, where we will introduce Smart Oblique. During ortho collection of area route tasks, with Smart Oblique enabled, the aircraft gimbal supports capturing at 3 angles during flight: left, ortho, and right, reducing the flight route density and increasing data collection efficiency and vertical accuracy. During oblique collection of area route tasks, with Smart Oblique enabled, the gimbal can capture images in 5 directions simultaneously: downward, left front, right rear, and right front along a smart flight trajectory, significantly enhancing the field operation efficiency of oblique photography. The gimbal angle option adjusts the Smart Oblique shooting angle, which defaults to 45 degrees. If there is a significant height difference among buildings in the mapping area, increasing the gimbal angle is recommended to ensure more comprehensive coverage of upper building levels. In mapping areas with a dense distribution of buildings, decreasing the gimbal angle enables the capture of more images between floors. After setting, an S-shaped route will be generated based on the default parameters. When relative to takeoff point is set for altitude mode. The route altitude refers to the relative height from the takeoff point to the aircraft's operation altitude. When the altitude of the takeoff point differs from the mapping area, adjust target surface to takeoff point. When the target surface is higher than the takeoff point, the value is positive. When it is lower, the value is negative. The value is calculated by subtracting the altitude of the takeoff point from the altitude of the target surface. When selecting AGL, altitude above ground level, terrain follow will be enabled. You can choose real-time terrain or select DSM files. Set course angle and upon completion actions. In advanced settings, set target surface to takeoff point, side overlap ratio, and frontal overlap ratio, as well as parameters including route start point, takeoff speed, and the bypass option. During the operation, choose an open environment for takeoff. The takeoff point ground should be flat and clean, free of small stones, plastic bags, or other debris. Take off from a nearby higher location to obtain better aircraft signals. Checkpoints can be evenly set within the mapping area for data accuracy verification. Unfold the aircraft. After it is powered on, retrieve the task in the flight route function of the DJI Pilot 2 app. Tap the button to adjust the flight route parameters as needed. Enable RTK positioning on the precise positioning setting page. The RTK service type can be set as DRTK base station, network RTK, custom network RTK, and DRTK3 relay station. You can also tap the flight route icon in the camera view to quickly create, edit, and select flight route tasks. Tap to upload the flight route. Set pre-flight check and mapping checklist. After confirming all the settings, start the flight task. During the flight route task, pay attention to the battery level, the RTK status, available shots on the microSD card, the image exposure information, and the obstacle avoidance status. Tap to check the real-time progress. If a single flight cannot complete the task, the aircraft will record the breakpoint location. After a battery replacement, the task can be resumed from the breakpoint. Run DJI Terra and create a new task. Select visible light, and then add the task data. In Aero Triangulation, Advanced, GCP Management, add some checkpoints to check the accuracy of aero triangulation. Select the model and set output coordinate system based on task requirements. Click to start reconstruction, and then the desired results will be generated. Thank you for watching.